The Elements of Non-Euclidean Geometry by D.M.Y. Sommerville. Chapter 2. Elementary Hyperbolic Geometry. Section 1. Fundamental Assumptions or Axioms. In establishing any system of geometry, we must start by naming certain objects which we cannot define in terms of anything more elementary, and make certain assumptions from which by the laws of logic we can develop a consistent system. These assumptions are the axioms of the science. The axioms of geometry have been classified by Hilbert under 5 groups. 1. Axioms of connection or classification connecting point, line, and plane. 2. Axioms of order explaining the idea of between. 3. Axioms of congruence. 4. Axioms of parallels. 5. Axioms of continuity. Without entering into these in more detail, we shall assume as deductions from them the theorems relating to the comparison and addition of segments and angles. The method of superposition can be used as a façon de parler. Strictly speaking, a geometrical figure is incapable of being moved. Lines are not drawn, nor are figures constructed. It is only the act of the mind which fixes the attention upon certain geometrical figures which already exist, developing them out, so to speak, like the picture on a photographic plate. And when we speak of applying one figure to another by superposition, all that we mean is that a comparison is being made between the two figures and certain results deduced by the axioms of congruence. When a geometrical figure, e.g. a line or a point, is spoken of as moving, we are really transferring our attention to a succession of lines or points in different positions. The measurement of angle is independent of the theory of parallels. Vertically opposite angles are equal. The sum of the 4 angles made by 2 intersecting lines is an absolute constant, and 1/4 of this is a right angle. An absolute unit of angle therefore exists. A flat angle, which is equal to 2 right angles, is generally denoted by the symbol pi. Through a given point, only one perpendicular can be drawn to a given straight line, the usual construction for this being always possible. The question of the numerical value of pi, or what is the same thing, of the unit of angle, need not concern us until we come to consider trigonometrical formulae in section 39. We may, however, state at once that when pi is treated as a number, it has just the value which we are already accustomed to assign to it, namely 3 1/7 to a rough approximation, or accurately 4 times the sum of the infinite series, 1 minus 1/3 plus 1/5 minus 1/7 plus ... But it is necessary to warn the reader that pi does not stand for the ratio of the circumference of a circle to its diameter. For in non-Euclidean geometry, this ratio is not constant, and the radian, or unit angle, in terms of which a flat angle is represented by the number pi, does not admit to the familiar construction by means of a circle. We shall assume, as deductions from the axioms of congruence, the congruence theorems for triangles, Euclid 1, 4, 8, and 26, and those on the base angles of an isosceles triangle, Euclid 1, 5, and 6, which imply the symmetry of the plane. The theorems relating to inequalities among the sides and angles of a triangle, Euclid 1, 16 through 20, are true within a restricted region. In particular, the theorem of the exterior angle, upon which the others depend, is proved in section 6 to be true without exception in hyperbolic geometry. An important axiom of order, which must be explicitly mentioned, is Pasch's axiom. If a straight line cuts one side of a triangle and does not pass through a vertex, it will also cut one of the other sides. Side being understood to mean the segment subtended by the opposite interior angle of the triangle. A large part of geometry can be constructed without the axioms of continuity, but we shall in general assume continuity. The watershed, so to speak, between Euclidean and non-Euclidean geometry, which we are about to develop, is the Axiom of Parallels. The Elements of Non-Euclidean Geometry. This book was written by D.M.Y. Sommerville, M.A. and Doctor of Science. It was published by the Open Court Publishing Company, London, G. Bell & Sons Ltd. in 1919, and now is in the public domain. It is being read by Jim Renholt, with programming and illustrations by Jim Renholt in 2019. Thank you for listening.